Well, welcome everyone. And as Carla reminded me, just want to let people know that we're recording this session so we can post it for people to look at later. So if that's an issue for you, feel free to leave the session. But I wanted to thank everybody for taking the time out of your schedule on a Friday to join us for this discussion. So if you're on the East Coast, feel free to have your lunch. And if you're on the West Coast, breakfast. And in Europe, hopefully you guys are having a cocktail. How we're going to structure the session is our panelists are going to give a brief overview of their processes for recycling textile materials. And then we'd like to spend the rest of the time having a discussion with our audience about the opportunities and the obstacles that you're encountering when trying to reutilize post-industrial textile waste. So everyone has access to audio. We haven't muted everyone, so feel free to speak up when you have a comment or a question. And if you're not speaking, please mute yourself just so we make sure that we can reduce background noise. If you don't want to use audio, you can also use the chat box, and I'll do my best to monitor that, and then I can raise a question or a comment that you have. So, okay, enough with the logistics. Let me share my screen for us. Good. There you go, and hopefully that's visible. I wanted to give a little bit of background or quick context for the Accelerating Circularity Project, which this session is connected to. But before I do that, I want to introduce our guest speakers. Our first speaker will be Chad Bullock, who is the Global Vice President of Brand Sales for Unify. And Chad is going to talk about Unify's efforts to mechanically recycle polyester textiles. Our second speaker is Maurizio Crippa, who is the founder and CEO of Green. That's how you pronounce, let me advance. Hold on one second. I'm now having technical difficulties. There you go. For some reason that slide got hidden. So Maurizio is founder and CEO of Green, a company that has developed a process for chemically recycling polyester-based materials. And then our last speaker is Michael Kinnemonth, who is the business development manager for Refibra, a process that Lenzing developed to recycle cotton and other cellulosic materials. And I'm James Ewell, and I am an associate director for sustainable chemistry for the North American region of for Anthesis, a sustainability consulting firm. And I am involved in the research portion of this phase of the ACP project. So in terms of ACP, our mission is, in a nutshell, to figure out how we can create more circular modes of production versus the current linear model that we have. And we are focusing on 3 fiber types: polyester, cotton, and regenerated cellulose. And we're also looking specifically in terms of how to create more linear circular systems, looking at chemical and mechanical recycling for those fibers. We have the first phase of the project is research, and we're basically looking at the landscape of stakeholders, trying to define the volume and the character of the waste. In my case, what's available post-industrial. And we are looking on the post-industrial side, we're not just looking at apparel, but we're looking at other industry sectors, so contract, residential, automotive, and then pull that information together and create a map of where there are opportunities and also where there are gaps that need to be addressed in order to facilitate more circularity, and then we will be reporting those results out to the larger community. I wanted to give you the link to the project website where you can find a lot more detail about the project. And I also wanted to point out in particular, on the website, there is a page which you will find surveys. One is for post-industrial for fiber and yarn, and one is for fabrics. If you would, those of you that are manufacturing those products that are on the phone, please look at the survey, and if you would, provide information, because it's really critical. This data is not publicly available, and it's very helpful for us to understand what the opportunities are for creating more value. The founding partners for the project are the ones you see on the screen, and 3 of them are with us today to talk about their processes and their interest in this topic. I also wanted to give a quick shout out to the companies that have funded the first phase of work, which is Gap, VF Corporation, the Walmart Foundation, and Target Corporation. So why don't we have, Chad, if you will share your screen. Let's start with you and your presentation.
Okay, bear with me.
And you know what? I think I do have to stop sharing because I'm the host. Yep.
Okay.
Okay, we've got you.
Is it back up? Okay.
Yep.
So my name is Chad Bullock. I work with Unify. With Unify, we've been recycling polyester for more than 12 years now. We're doing a lot. We have a lot of recycling, whether that is post-industrial or post-consumer. Today, what I'm going to focus on primarily for this webinar is going to be around post-industrial recycling, and primarily around post-industrial recycling using a mechanical recycling process. So really quickly, if everyone can see here, and some of the wording in here, it is post-consumer, but the waste that can go in this slide in the far left picture, it could be pre-consumer, could be post-consumer. It would go in through a mechanical recycling process. It would form into reprieve chip or resin, and then that resin would actually go into an extrusion process to form a POY that could go into a textured yarn, which is what you're seeing in the last slide there. I've got a few pictures of the process. This picture actually shows a multitude of color that you're seeing as going into the machine. In a mechanical recycling process, you're not going to remove that color. So that color that is there is going to remain there. In mechanical recycling also, we're trying to get 100% polyester, or we can handle a little bit of spandex, but products that create issues for us would be cottons, wools, anything like that. Those will not process through our mechanical recycling process. The material will go up a conveyor. It will actually go into a shredding process where that material is actually being shredded into smaller pieces. And then it goes into what is basically like a big extruder or a big auger. It's going to get melted down. And the end product that you end up with, again, because we're not removing color, if you remember in the first picture I showed you that had the process kind of drawn out, the resin or the chip that was shown in that picture was all white. As you can see here, this has got multitude of color in it. So that when you end up, you're ending up with chip and resin that shows as different color. Again, because we're not removing the color. So if we're going to go into a new product for this, we would have to go into something that you would either make into a solution dye black or some darker color to to get rid of the color that you get in the when you're actually producing the chip from the waste material that you're receiving. We do quite a bit of this now for a multitude of customers, and you know, we're continuing to expand on this as we are seeing a big demand, whether it is what we call textile take back from a cut and sew realm, or we're also starting to see a lot of requests from brands now with trying to see if we can bring full garments back, or garments back that are either being returned or could be being removed from the store floor. So I didn't put a lot of detail here because I wanted to kind of leave a lot of time for question and answering. But so I think that's pretty much my last slide, and I can turn it back over to the next presenter if you would like me to.
That sounds good. Thanks, Chad.
Mm-hmm.
Maurizio, you want to go next?
Okay. Can you see my screen? Okay. We used to do making this logo, making plastic circular, because we work typically not only with textile, but also with bottles and packaging. And I have to say that the two words, they are starting to talk of the recycling side, not just only in one way, but because until now we got a lot of one-way talking. It means that the bottles, especially the color one, where they got a destination for yarning. This was this recycling line. But the point is that the major part of the production of PET goes directly to textile and not to bottles. Then when I talk to people with bottles, I shock them with this picture. The problem is that, mechanically speaking, the true recycling of polyester and PET is very limited to few fractions. The colorless one. The colorants and the other contaminant present in the resin, they impede the full recycling. This is what we talk downcycling. But if we remove this contaminant, we can go to upcycling. It means that we can go back to the virgin polymer, and then on top of this, we can recycle complicated material, like for example, textile we mixed with cotton. We're going to see an example later. That's what we do. We do depolymerization, and then we produce the virgin PET. Our process is a self-sustaining process. It means that we need, of course, the feedstock, which can be packaging or clothes or textile in general, and we need energy. And the chemicals that we need for the reaction are produced on site from the byproduct of the reaction, which is table salt. The table salt, through an electrolysis process, is used to produce the chemical we need for the reaction and for the workup. Then the input is the feedstock and energy, and the output are monomers. They can use, then they are used to produce a new polymer and then new product. Then the process is completely sustainable. We have a low CO2 impact compared to the polymer produced from oil. It's a 60%. And then of course we have less than 60% less CO2 produced compared to the virgin polymer. We started many years ago, but then we have a reactor. This is our first industrial reactor, because we do with microwave. Then we developed a purification process on site to recover the monomers. And now we are building a demo plant with the capacity of 1,000 tons per year. As you can see here, we treated really complicated material, blended material, nylon, lycra, rayon, and cotton. The full depolymerization happens in 10 minutes, and it's a flowing through reactor. Here we have an example of white bottles, colored bottles, plastic trays, And this is a textile containing 30% of polyurethane. And this is the polymer produced with the mix of monomer coming from this feedstock. You can see it's perfect. This is an example of cotton that we recently got as a result. We received this material, which is a polycotton. And through IR, we can clearly distinguish the cotton fraction and polyester fraction in the material. And after reaction, here is the cotton. The cotton is completely clean of all PET. And this can be suitable, for example, for rayon, for pulp. This is the Textile I mentioned before, containing quite a good amount of polyurethane. And we got the monomers perfectly clear. Here we have the analysis. This is the one of the monomers, the liquid part, the MEG. And these are the results of the terephthalic acid, which is the other monomer, in different situations. As you can see, starting from bottles or textile, we have always the same result, perfectly in spec. Means that the purification process is very robust. This is very important when we talk about waste, because you can't modify your process because the waste is changing. Our vision is to satisfy the pledges that all the brands, they put it in place and they took very serious. And in how we can catch these pledges, just because we start working hardly recovering scraps from the industry, for example, scraps from mechanical recyclers of bottles, or even textiles, then we need to recover monomers back to the PET producer, no more waste. We established an industrial advisory board trying to cover all the functions that, all the positions that we have on the two streams, the stream of apparel, the stream of packaging. As you can see, we try to cover everybody. Some logos are faded because we were not allowed to use it. We started in 2011 and we are developing, and we won the Innovation Radar Prize, which is the best innovation of Europe in December 2018. I think I'm fine. Thank you. I leave the stage.
Thanks, Maurizio. Wow, you guys are going fast. That's good. We'll have a lot of time for discussion.
Yeah, it's much better, I think.
Michael, want to try to load yours up? And you're still on mute, Michael, just FYI.
Okay.
There you go.
You see my screen?
Yep,
Okay.
you're ready to go.
So, hello everybody. Just like Chad, I haven't put really any detail in here. I thought it would be brought out in the discussion afterwards. So, we're in the cellulose business, and of course, cotton dominates the cellulose business, and for mechanical recycling in cellulosics, you only end up with a downcycled product. So the way we started to tackle this is that we do chemical recycling. So we're a cellulosic business, and we make three products. We make viscose and modal, which are produced on the viscose process, and we make Tencel lyocell, which is produced on the lyocell process. Cellulose is our business. It's estimated that there's about 1.5 trillion tons of cellulose globally. So it's an enormous resource, and basically we're relying on photosynthesis to produce the trees that we use to convert into textile fibers. That is our value chain. So we are a business that relies on converting wood. And I make that point because in our recycling part of our business, we're trying to convert a different type of cellulose. So we are a wood-based business, and we supply to both textile applications and technical applications like nonwovens. The viscose process you see on the left there, a process that's over 100 years old, chemically and energy intensive, and then you see the lyocell process on the right hand side. And it's the lyocell process that we've chosen to do to make a recycled product. So a much more elegant process, being commercial now for just under 30 years. Wood-based fibers, although they only make up a small amount of the number of fibers made a year, we're about 6.5%. It is the fastest growing area because there's a lot more interest in cellulose for many different industries now. So our expertise is wood cellulose, and so the recycling opportunity for us has made our business a lot more complex. The product that we make, we do the recycling, we brand as Refibra. It's what I would call Tencel 2.0. So Refibra is made on the lyocell process. We produce pulp from wood to convert into fiber. And in our Refibra process, we are taking cotton scraps and we are pulping those. We are removing all the dye stuffs and all the chemistry to make as pure a cellulose as possible. Then we put it into the lyocell process and produce a fiber which is a virgin fiber and is the same quality as Tencel. So there's no downcycling. Effectively, it's the same fiber. So if you want a non-downcycled fiber in cellulose, as of today, it cannot be cotton to cotton. The only way to do it is the way we are doing it, which is to take cotton as a cellulose base, and then you produce a man-made cellulosic. So other parts of our business we're trying to do on recycling as well. So we have our Refibra process. The lyocell process itself is a closed loop process where we recycle and reuse the solvent. And on our other businesses, on our pulp businesses and on our viscose businesses, we do a lot of recovery of product and recycling. So you can see some of the core products that we make there. We recover a lot of the tree that we can't convert into cellulose fiber. We burn it and we produce green energy. So there's a tradition within our business to try and do recycling wherever we can. Thank you.
That's great. Thanks, Michael. Thank you to all the speakers. So what we want to do now is open the floor for questions from the audience. Thought we'd start by people who want to clarify any of the information that's been presented so far. Have you asked questions of whomever you're interested in exploring that a little further? So we've gotten some, I'll just kick us off with a couple, Chad, that one is, why can't you separate other fibers like cellulose or protein during your dissolution process? So I think some clarity is needed about the actual process.
Sure. I mean, we're in a mechanically recycling process. You're basically using heat and pressure to melt the material. You're not doing anything like that. So you're just melting the material. It's going through some filters to remove impurities. And those cellulosic materials and wools and things like that, cottons, wools, anything, those will actually create and clog and stop up our filters extremely fast, where but we're not trying to remove any of the fibers. We're just melting and with heat and pressure to create a new resin.
Yeah, and dissolution is a possible process. Is that something that Unify is looking at in the future to deal with the issue of colorants and other additives to just kind of get it back to pure polymer?
And we're exploring a lot of different types of recycling methods right now. Primarily what I'm explaining to you today is the method that we have internally in our facilities in the US. But we are exploring a lot of different other recycling methods for future use. Yes.
Okay. Michael, I've got a question for you. They said, I'm curious if Lenzing has explored composting applications for the non-usable Refibra byproducts versus burning for waste to create green energy.
Well, we know that I mean, cellulose is compostable, and we have international certificates to prove that. If you were to, I mean, can you imagine that even the industrial waste, say cotton is around 25 million tons every year, annual crop, and say, let's say, I don't know, say that 10% of that goes to waste. I mean, that's cutting waste is about 10% of everything that goes into garments. You have about 2 million tons of waste there. What size of facilities you would need to compost that kind of amount? I do think in future, and I don't know when that is, maybe 10 or 20 years down the line, that most households will have composting bins, and you will be able to compost your garments there. It's not an industry that we own or that we are looking into. All we know that our fibers are compostable and biodegradable.
Yeah, and this is pretty standard practice for the wood or any fiber industry to take non-usable or unusable byproducts and burn them for energy. One, because they get renewable energy credits. Yeah.
I mean, the compostability, the virgin fibers are perfectly compostable. I think what hasn't really been studied is that actually what hasn't really been studied is, are the dyestuffs and the chemicals on there actually compostable? You know, are they leaching toxins or whatever else? And that's the biggest area that's not known today.
Maurizio?
Well, when we compost something, we produce, in any case, CO2 and soil. But when we burn, we produce CO2 as well. But when we burn, we recover energy. When we produce compost, we do not recover energy. If we burn cotton, we emit the same CO2 that was harvested by the plant 5 years before. Then, fine, what's the problem? On top of this, when we incinerate the cotton, we burn all the dyes.
Yep. Any other, those were all the questions that were submitted through the chat. Does anybody want to ask any questions of the speakers about their process? Oh. No, and if you're trying to talk, you might be on mute, so take yourself off mute.
Hello.
Hey there.
Maybe
you wanna ask
Michael
a
can
question?
stop the screen sharing. Then we can see the videos, people. Thanks.
Yeah, so I would like to know, for all three of our speakers, how likely is it for you all to use the dyes as a way to collect the dyes as a way to be used for another system? Can the dyes be also recycled, or is that completely trashed? Or not even trashed, but is it reusable?
Shall I? Well, I can only talk for ourselves. So for the lyocell process, we need a very high purity of cellulose. Anything in there that are contaminants effectively can cause a reaction within the process, and because the lyocell process is high temperature and high pressure, you get a self-fueling reaction which turns into what's called an exotherm, and you blow your plant up. And dyes are contaminants as far as we're concerned, because a lot of the colors, a lot of the chromophores are based on metal complexes. So things like copper, and they're highly reactive. So we have to remove the dye stuffs so that the cellulose is pure enough to put into our process. We are unable to recover dyes.
So they end up being a waste product.
Yeah, yes, they ended up. We have to strip them out somewhere. We have to strip them out chemically. I do know of a company in Italy who recover dyes off textiles. They don't recover them chemically. They grind them down to fine powder, and then they use those with a binder to reapply. But no, I mean, I don't know about the other guys, but we are trying to retrofit to a process that we have honed in decades. So our process is absolutely honed to take wood cellulose in a very effective way and produce fiber at a price that is acceptable to the market. Taking any other cellulose, even cotton cellulose, is highly inconvenient for us, I would say, because not all cellulose is the same. And so cotton cellulose has different degrees of polymerization, different porosity. It's got different additives in there from the textiles. It has optical brightening agents. It's got different solids in there, and we have to get rid of all those. So we are very efficient at turning wood into pulp and pulp into fiber, and actually trying to get cotton recycled into our product is difficult and expensive.
So that's a good segue, Michael, into I wanted to ask each of you to just quickly characterize what your ideal feedstock is for your process, and then we'll ask audience members how that stacks up against the post-industrial textile waste that they have available, because one of the things we're interested in is measuring that gap. So Michael, why don't you go first and just tell us, if you, on your wish list, what's the ideal food for your system?
Yeah, so back in 2012 or 11 or 12, I thought I'd found the golden fleece, as it were, because I naively thought that if I took hospital and hotel bed sheets and towels, which weren't coloured, just white cotton, that we'd have the perfect feedstock. But it turned out that those things actually, a lot of the sewing threads in there were not cotton, they were polyester. And every different country we looked at had a different way of actually collecting that waste and using it. And actually the cost of white cotton waste was pretty expensive as well, because it has other uses. And so a ton of white cotton waste was significantly higher than a ton of wood pulp. So white cotton waste would be our ideal feedstock, but today it's an absolute non-starter. And so the waste that we can afford is mixed colored cutting waste. So we know from the cutting table, at least, that we are taking something that is 100% cellulose, cotton, and we can, to an extent, collect things that are all of a similar color, because every different color will have a different dye stuff, and those different dye stuffs will have different metal complexes. And so what we need in our raw material is consistency.
Yeah.
And that is, for us, that's a problem, to get that consistency. And for us to process it to get that consistency adds a lot of cost. So at the moment, whatever we can buy the waste for, the actual processing of that waste more than doubles the cost of the raw material going into our process.
Mauricio, what about you? How would you characterize how wide is the index for what you can take?
Well, we in the process we are very flexible. First of all, I would like to answer to the question before about the dyes. The dyes are removed and disposed as chemicals. Then we do not recover the dyes. And the second, as a feedstock, as I showed, we can work with packaging or textile. Again, it's a matter of price. Evidently, we can depolymerize, we can recover polyester monomers from polycotton, but then I need a destination for cotton. Then, for example, if Michael wants the cotton, it's gonna very cheap cotton, maybe it's suitable for him, then this material as feedstock for us becomes interesting. But if I don't find a destination, I have to burn the cotton, then I have to pay a high cost for burning. It doesn't matter, there's no value. Then the problem is not technical, but economical.
Maurizio, what's the minimum percent of PET, like in a bale of textile waste, that you would process? What's the target for PET?
Well, the threshold is 70% net content of PET.
And then the balance can be any other fiber?
Yeah, we can work with unless it's 70% PET. It doesn't. I'm not saying that we do not accept 50%, but this will be mixed with something with a higher content in order to have an average around the 70-75%. But again, this is a matter of cost. How much it costs this material, or how much we are paid to dispose this material.
Yeah, and this is where post-industrial textiles are more interesting relative to some other feedstocks, right?
Yeah, because they're more under control.
Yeah. So this is the hope, because post-industrial waste streams are already semi-aggregated. There's control. The purity level is higher than we see in some other polyester materials. It makes a good target feedstock.
Correct. The packaging in Europe is quite stable as well, because being APR schemes implementing the packaging streams, then we have consolidated the collection and sorting. Then we have streams in Europe that come very controlled. I have plastic trays, 95% PET, 5% the rest, color, butter, and so on. But textile is much more interesting for us because my competitor, they can't deal with textile then.
Yeah. And Chad, for you on the feedstock, I noticed in your slide, you actually had garments that you were shredding. So it looks like there's actually a wider index of materials that you can take in too. And you mentioned that your process will tolerate a certain amount of spandex. So I was wondering what % that is. And then you said it's not tolerant of other things. If you could just repeat what would be a contaminant that you don't want.
Sure, and I guess if you ask me for my ideal feedstock, we'll start there. My ideal feedstock would be 100% polyester, no color. And, you know, a lot of that's going to be your textile waste off machinery that's producing, you know, we produce a lot in our extrusion process. So, you know, that is my ideal post-industrial feedstock. In the slides that I showed a lot of different colors. You know, a lot of that could be cut and sew waste. And in that situation, we would still like 100% polyester. We can tolerate up to about 10% spandex content. The products that we cannot tolerate would be cottons, wools, things along those lines. Those will not process through our process. And you know, the other thing that we have to be cognizant of are any type of finishes or certain types of prints. Those things can also create certain types of possibly DWR finishes can create issues. Also, you can run into problems with thermosol, or you know, certain types of prints and things like that that can also create issues.
Okay, thanks. So folks on the phone, the audience, what kinds of materials do you have available that you have questions about whether they have value in any of these systems? Somebody want to offer an example?
I'd like to chime in if I can. I work for West Point Home. We're a home and hospitality textile manufacturer. I was kind of surprised to hear the need for post-industrial waste recycling. I mean, we've been doing that for 100 years. Pretty much 100% of our waste has already been being recycled. The post-consumer is really more where we're concentrating right now. And like Michael said, sheets and towels are from the hospitality industry seem to be the low-hanging fruit. I'm surprised that you're having to pay for those if it's post-consumer, because we're finding people that are throwing those things away. They're desperate to find ways to get rid of it easily. The problem seems to be the collection of things. We found that we actually find markets for it and we can get paid for it. But I don't think the hotels and resorts are looking to get much pay for it. They want to find a way to get rid of it sustainably. It's just been hard to get the hotel chains. I mean, they talk a good game, but they don't really, if it's going to be much trouble for them, they don't seem to be very interested. We're working on that. And there are companies around that will collect it for free and pass it along. So, you know, that's kind of my feeling about things.
Yeah, thanks, Eddie. Appreciate it.
I would just say that there isn't a consistent structure for collection of and sorting of waste. You know, if you go to Europe, virtually every different country has a different system, and some are more sophisticated than others. And I think the reality is that most of the waste guys have been clinging onto the wreckage for decades until we in the last few years when recycling has come into the psyche of everybody. So there isn't especially on the cellulosic side, there really isn't a consistent structure to the waste business to be able to dip into and be able to have the conversation about collecting things. So that's where we're struggling. I don't know what happens on the PET side. There seems to be more structure to that industry.
This is Carla. I just wanted to weigh in on what's being said here. So the whole reason to be for accelerating circularity is the fact that we're very aware that there isn't a structure. And so the reason that we're having these webinars is we want to put the parts of the industry together. These recyclers who need the inputs, the companies who may have the inputs. And our goal is to do the research that's going to allow us to help set some standards, to talk to people about, okay, people, we've been told that they can collect anything, but it has to have a market. And so we've got to put these things together in a way that everybody knows that if it gets collected, it gets sorted, it's going to have a home at the other end. And for us to do that, we need to start figuring out what are some of the standards for sorting and separating based on the needs of the recyclers so that it will have a home.
Thanks, Carla. That's an excellent point. Yeah, and as much as we might look at post-industrial as being low-hanging fruit, unfortunately, a lot of it is going to landfill or incineration, at least on the polyester side. So, but the toolkit for processing these materials and the complexity and diversity of materials is expanding. That's what's really exciting, and why this project has been launched, is to actually try to measure what the value of the contribution of those technologies will be. I noticed we have Dr. El Maghazi. I noticed you're on the webinar. Now, I didn't know if you wanted to comment. I know you've done research on cotton recycling. If you had anything you wanted to add.
Actually, I'm here to learn. I'm not here to contribute. You guys have, definitely doing your job, and I'm enjoying this. I'm going back to Mike on the lensing, the use of cotton scraps. And it sounds like it's mostly cotton sew, so it's all fabrics or in the fabric form. I'm just wondering about the other type of waste, especially in the spinning process. I mean, in the US, we produce almost 20 million cotton bales every year, and there is about 20% of that. That's all what I would consider fiber waste. It's fiber waste because they are intermingled with a lot of trash, a lot of vegetable foreign matter. So how can these waste be used? Some of this waste, of course, is being recycled into yards and fabrics, especially the common oils. But there is another 11–15% of all of that ends up every year in the landfills. So is there any ways to use this type of waste, which comes in huge amounts, into the lensing process?
Well, you make a good point. Maybe there is. I think that what I would call the better or cleaner waste that the mills produce, like you say, they probably respin it. And they've always respun it, except in the 80s and 90s, they didn't admit to respinning it because it would be seen as affecting the quality. Now they can tell everybody they're respinning it and charge more money for it. But the lower, what I'd call the lower grade waste is probably a lot more vegetable trash in there, which we haven't even looked at, and I don't know if it will be suitable or not. And maybe that's a good PhD project for somebody. I mean, even pure cotton for us is not ideal because the degree of polymerization is different to wood. And for the lyocell process, when we add the cotton waste, the viscosity of the dope increases significantly. So in very simple terms, it's very difficult to push that higher viscosity dope through pipes and spinnerets. So if you then look at other cellulosic bases, it may be hemp or nettles or any other type of thing, you've got a different DP distribution yet again. So if you were building a fiber plant from the base upwards, maybe you could build it to accommodate all these different types of celluloses. As it is today, we are trying to retrofit things to something that we have honed for for wood cellulose. I've no doubt in the future that we will look at this because, as you say, the amount of waste, even from the spinning mills, is significant. And again, its collection, it makes no sense. You know, majority of spinning and weaving is going on in Asia, and we're trying to produce refibra in Europe, moving things around the world that are defined as waste are other issues. You know, the different countries have different rules about importing and exporting waste. So there's a lot of barriers to this, but you make a good point.
Hey, Maurizio, I know you were trying to raise a point.
I was on the collecting before, but I think the moment is past.
Okay, we actually have a question that's come through in the chat for you, Maurizio, and so how and when do you think you can scale up your pilot from 30,000 to 50,000 tons, and how will you manage different kinds of mixed post-consumer waste? What about the cost? How can you compare TPA and MEG to virgin? Like, how will you compete with virgin cotton?
Our pilot will be 1,000 tons per year, and then the 30,000 tons plant will be 3 lines of 10,000 tons parallel. Then the scale up will be from 1,000 to 10,000 tons, not 1,000, 30,000. The fact that we have modularity, we're gonna process different schemes in 3 modules. For example, if I want to separate cotton, I can use the line 1 for polycotton. Then I can use the line 2 for PET polyethylene, and then I recover the polyethylene as I do with cotton in line 1, and the third one can be mixed. Then with modularity, we can process different streams. Despite we have a high flexibility on purification, then it's not really a problem. The second point is the cost. The cost of the monomers for us is competitive with the cost of monomers from oil. Then we are fine. Despite it, there is a case very interesting that is moving in the world, that the RP recycled PET food grade now, because the high demand from the brands is more expensive on the market, is 40% premium than PET virgin. PET virgin costs 1,000 euros per ton, and the recycled PET food grade is 1,400 euros per ton, which is very interesting.
Other questions from the audience about one example I thought was interesting. I was talking to a textile mill for polyester, and they said that one thing that they have in volume that they can't find a very good home for is leftover yarn on the cone, and many times the cone is PET itself, And to get it mechanically processed, you have to try to figure out how to split that cone, get the yarn off of it. And it's very hard to make a process that's economically viable. So one thing that's exciting about Maurizio's process is that it still has to be shredded, but the cone doesn't have to be separated and can go into the process. So I didn't know if there are other forms of waste that people have you're trying to find a home for and you haven't been able to find any end markets that are interested in processing it. Are there other examples that we can point to? Anybody? No? Okay, let me go. Chad, there's a question for you about a metal trial.
For trims.
Trims. Metal trims. Okay.
Yeah, I mean, any metals, any, whether they're buttons, metals, anything like that, that would not be a PET base, those would have to be removed from the material before we put it through our process.
And somebody made a statement that they're having trouble finding a home for pillows, and both on the collection side and I don't know if that means down filled or polyester fiber filled, but those seem on the cotton side that might be good food for lensing, and on the polyester side for green.
This question regarding pillows is very interesting because, and it's connected to the question before regarding post-consumer collection. By 2025, the European directive obliges the member states to implement a separated collection of textiles. It's going to be a nightmare because we were obliged to spend money to collect, sort, separate it, and doing what? That's exactly what Carla said before. We need to find a destination, and then all the chain is going to be in place. Otherwise, if there's no destination, what we do with this? Nothing. This is the answer to the pillows. Keep in your home till 2025.
That's one solution.
Yeah, I really believe that, I've done a lot of research on what's going on, and I agree 100% that if we can achieve circularity, it would be fantastic. But what we're really missing is an integrated concept of sustainability. In one side, you find, for example, on the cotton production side, a lot of effort are being made to produce what you would call a sustainable cotton. But what sustainability in this case means, if you're going to take the cotton and you're going to have a great deal of waste, intermediate waste that amounts to millions and millions of pounds. And then as you go to the other side of the process, you're talking about a huge amount of dye and chemicals that you have to use to finish the fabric. So what I see missing in all these aspects is an integrated concept where it's not just an isolated effort in different segments of the industry, but rather an integrated concept that I can see from A to Z. So when I look at the end product and define it as being a sustainable product, then I can actually use measures that goes from the raw material all the way to the end product. The other side of the problem is definitely the fast fashion and consumers' consumption, and hopefully after what we've been through these days, people are going to start rethinking the whole process. It was really nice to see people not going out as often. I wish it did not happen due to this situation. But I mean, I look at my family and the other families, and a daughter of mine who would buy things that last 2 or 3 weeks and then throw it away. So for 2 or 3 months, she did not buy anything. I know that doesn't sound good business-wise, but it would be great if we can influence the consumer as well, because the end result is always in the consumer. As long as the consumer going in fast fashion, changing things so quickly, all the effort that we made will provide very little to the whole story. So that's just my view, an integrated concept of sustainability that touch upon every process in the whole supply chain.
That's great. Thank you. Well, and that's a great segue, a reminder that we have another webinar coming up on post-consumer. And I don't know if Tracy, if you're on, what the date, remind me what the date is. Day and
It's the 16th.
16th. At what time?
At noon.
At noon. Okay. And we'll be sending out info. So we're at just past the hour. I want to be respectful of people's time. I encourage you to go to our website where you can learn more about the project, and we hope everyone will stay connected to the project and be part of helping us to formulate some viable solutions. And please take the survey, if you will, so we're operating with good data, real data versus theoretical. I want to thank all of our speakers for joining us. Very interesting presentations. Thanks for your time, and thanks for the time of all of you who dialed in. Appreciate it.
Thank you.
Thank you.
Have a good weekend.
Thank you.
Thank you.
So bye-bye.
Bye-bye.